All right, man. So we're looking at adjacent angles here. And when we talk about adjacent angles, we're looking at an angle, and then what we're going to do is we're going to split it in two. And so now we have two angles. And when we have two angles that are sharing, that are touching like this, we call them adjacent angles. And then we already went over it, but adjacent means next to or joining.
Should I get my nose up?
Yes, please. And so when we look at angles 1 and 2, so angle 1 and angle 2, we notice that they are sharing they have a common ray, and so that makes them an example of adjacent angles. And so what would the shared ray be? Well, vertex would be B, so they have to share that vertex, but what would be the shared side? Not D, but B to D. There we go. So they have that shared side of BD, like you just said. And remember, when we're labeling an array, we start at the point that is stopped and go to the one that is continuing. Okay? So B to D. So we're looking at the definition of a adjacent angle. Yes. Okay.
Oof.
Okay. So they have to have a share a common side, and they have to have the same vertex. And then this one's one that doesn't make a lot of sense for us, but we're just going to put it down there. It says that they have no interior points in common. And what they're talking about interior points, we're just not going to worry about that one, all right? That one's just part of that further definition, but it doesn't really make a lot of visual sense for us right now, all right? So when we look at these two angles, we have 1 and 2 are adjacent because they have the same vertex at R, and then they have that common side RM in the middle. All right? That part is with both angles. So now we're going to look, and we want to determine if angles 1 and angle 2 fit the criteria to be an adjacent angle. Do they fit? No. No, they don't. Good. Why not?
Because they're not sharing
They have a vertex because they both have the vertex at B, but they're not sharing a side. That's perfect. Because there's a third angle in the middle that is separating them. All right. So when we talk about adjacent angles, I like to use classrooms as an example. My room is adjacent to Miss Lee's room. I am sharing a wall. This wall right here. If I pound on this wall, she hears me pounding on that wall because we are sharing a side. But does Miss Miller hear me pounding on that wall? Probably not. Because she's all the way on the other side of Miss Miller's room. So although I am adjacent to Miss Lee's room, and Miss Miller is adjacent to Miss Lee's room, Miss Miller and I are separated by that space. All right? That makes sense?
Yeah.
Cool. So they have a common vertex, but no common side. Is why they don't fit. All right? So let's look at the next one. 1 and 2. 1 and 2. Yes. So if we look, their common vertex is G. Right here in blue. And then if I draw both of these angles, angle 1 right here, and angle 2 right here, do we notice how I colored that side with the blue, or with the green and the red? If I can take a pencil and I'm drawing adjacent angles, if I draw one and then draw over the same line, the entire line, then they are adjacent. So, they have to share that entire side though. So again, they have to have that same vertex in order for it to share the entire side. So let's look at the next one. So yes, we already answered yes. They have the same vertex and a common side. Excuse me, side with no interior points in common. Looking at this last one. Going through those two parts. Do they share a vertex?
No.
No. So we're not. If they don't share a vertex, they cannot have a common. They can't have a common side, and they can't have a common vertex. So the vertex of angle 1 is L. Right here is L. The vertex of angle 2 is J right here. And then if we look, when we look at these two angles, angle 1 goes here to here. And angle J, or angle 2, goes from here to here. Now part of that line is together. There's part of it that's blue and red, but it's not the whole thing.
Yeah.
Which means that they don't have a common vertex or a common side. They don't have either. And so, no, they do not have a common vertex or a common side. All right? So we're looking at this. This is just a little bit more of that example. The side of angle 1 that we were looking at that I just highlighted was L to N. And then the side of angle 2 was J to N. And so we notice when we write that down, they're different rays. In order for it to be the same side, it has to be the same ray. All right. Looking here, it says adjacent angles and linear pairs of angles determine whether angle 1 and angle 2 are adjacent angles. So looking at these two, going over those two requirements for adjacent, do they have a common vertex and a shared side? No? No. So you're saying no, and that's good because if we look at it, angle 1 right here, and angle 2,
Parallel.
kind of, they're just separate, right? They're just two separate angles. This would be like they're close to each other, but they're not actually next to or joining. This would be like my room and Mr. Colazo's room. We're close, but we don't share a wall. All right, so we're not actually adjacent and next to each other. What about this one here?
Yeah.
So we look at this one here. Angle 1 and angle 2. The green and the blue cover the same line, which means that they are adjacent. And in this example, the non-common sides of the adjacent angles form a. So we're looking at this, the non-common sides, right here, x to z. A straight angle or a straight line. And then these angles, whenever two adjacent angles, they have to be adjacent. If adjacent angles form a straight angle or a straight line, we call them a linear pair. A linear pair. Linear pair. keep going. We'll catch you up as we go, all right? Because I have next class with you as well. So, looking at what a linear pair means, linear pairs of angles are two angles. It's when two angles form a linear pair. It's if and only if. If and only if. If and only if. You guys ever heard that term before? So like, teachers use it all the time, right?
This happens, you do that.
Alright guys, I will give you a pizza party if and only if everyone gets an 80 on the test. Right? I will give you a free day if and only if everyone is on time for the entire week. Things like that, right? Make sense? You have to have all of the things happen. These are the things that have to happen for a linear pair to be true. The angles have to be adjacent, and their non-common sides are opposite rays. And what did we say when opposite rays occur? What did it make? What kind of angle? A straight angle. So if you want to underline opposite angles or opposite rays and put straight angle slash line. They have to make a straight angle or a line or opposite rays. Those are all synonyms for each other. They all mean the same thing. So, when we look at this, we understand that ray BA, right here, and ray BD form line AD. And so when we put those two angles together, they made a line, and it ends up being 180. All right? Make sense? So, looking at this, it shows that in the figure CM and CE are opposite rays. I'm going to highlight that with a pen. CM and CE are opposite rays. So looking at this, we want to talk about what angle forms a linear pair with angle 1. So remember, they have to be adjacent. So here's angle 1. So what side does this new angle have to have? There's two sides that it has to have. In order for it to be adjacent, it has to share a side with angle 1. And then it has to end up making an opposite ray with CM. What is the opposite ray of CM? CE. So we know that we're going to have letters C and E in our angle. What would the other letter be? So we have to get all the way to here. And I have to be touching angle 1. Tell me when to stop when I get to angle 1. Did I make it? So right here. So when we look at this, now we're going to make a new angle right here. We went from letter E to C to A. Can we see how that angle in the middle, or that angle the new angle that I just made, has a shared side with angle 1. So angle 1 was ACM. And then I needed to have those two letters in my new one. And if I look, ACE is the second angle. Wrote this backwards. We're going to erase that really quickly and just let it come clean with the... So we have ACE as our answer. If we look, this is what we just talked about. ACE and angle 1 have a common side of CA. The same vertex at C and opposite rays CM and CE. So they made that straight line.
Do we write that in a box?
Write it below it since the box is too dark. Sometimes I print stuff out thinking it's going to work and then it doesn't. So we're going to finish up on this page right here. And the next question says, do angle 3 and angle TCM form a linear pair? Now remember, a linear pair, when we put it together, has to end up making a straight line 180. So Azra, when we look at this, these two angles here, angle 1, 2, or from angle TCM and angle 3. So here's TCM. Actually, I'm going to do that as angle 3. Match the colors. Here's TCM. Now when I put those together, does that new green one make a straight line? Is that angle that I made, is that green one a straight line? Nope. So, we are going to say, does it form a linear pair? No. Their common sides are not opposite rays, or they are not equal to 1, or the angle is not equal to 180. We have adjacent angles, but not a linear pair. So it can be a linear, or it can be adjacent angles without being a linear pair. But in order to be a linear pair, it has to be adjacent. Okay? The best way I can ever think of this is when we talk about when people talk about ethnicities. So you're Salvadorian, right? So in order to be Salvadorian, Kevin also has to be Hispanic, because the Hispanic is a larger pool of a culture, right? Hispanic includes almost all of South America, all of Central America, but it's a mix, right? It's a more ambiguous term. So we say Kevin falls under Hispanic or Latin, Latino, but when he says, well, when someone says, Kevin, what are you? He's going to say, I'm Salvadoran. I'm Salvadorian. Right? So that's what we're looking at. Adjacent would be like saying Hispanic or Latino. Linear pair would be that more specific kind of Hispanic or Latin culture, saying Salvadoran. Alright? Does that make sense? It's more specific. We also talk about that when we get into shapes, like rectangles and squares. Rectangles are like that Hispanic overture, and then we get smaller and we say squares are a special kind of rectangle. Alright? So sometimes we talk about things and they're more than one thing. And we try and find the most specific thing. So in this situation, when we're talking about adjacent and linear pair, adjacent is a bigger umbrella, and linear pair is a more specific, smaller umbrella. That's all we're going to do for today. Go ahead and put things away, and we will continue on this tomorrow. We're going to start with some of the work that I gave you in that packet. I will get you guys to the right page. Starting tomorrow, we'll start on certain work, and then we'll work through it, and then continue on in the notes.